Hey, so in this video, I'll be covering the breadth first search algorithm, right? And I'm also going to be explaining about the logic or the approach and then the code itself, right? And the code is going to be in Python so that you can easily convert it into your favorite language, maybe it's JavaScript, C#, C++, C, whatever it is, right? And if you are writing in Python, then that's a bingo for you. So consider this graph, right? Consider this graph. We are given this graph, and a little prerequisite to this video is that you should know about the basics of graph. So the graph, what are the basics of graph? When I say the basics of graph, what do I mean by that? I mean nodes, edges. What are the type of edges? Undirected edges and directed edges. Then nodes are kind of like self-explanatory. So in this case, I'll just explain overview. So the red circles, right? And the values written in them are kind of the node values, and the red circles are the nodes itself. So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8 nodes, right? And we have edges here as well. So what are edges? Edges are basically connectors which kind of connect two nodes to each other. So in this case, the 1 is connected to 2, 1 is connected to 3, 2 is connected to 4, and then for example, 5 is connected to 8, 6, and 7, and so on, right? This diagram might be looking like a tree, right? Because hey, the tree is basically a data structure which kind of represents a hierarchical kind of a format, right? So in this case, you can kind of assume this as a tree, right? But it's at the end of the day, it's a graph in my case, right? So this is not really a tree, but this is a graph. But I have drawn this in the format of a tree so that you can understand breadth first search easily. So what is really breadth first search? So breadth first search kind of in its own terms means that we are going to be exploring the representation, the graph representation, right? Breadth wise and not depth wise. And why am I saying depth wise? Well, you can kind of check my previous video. I've explained properly about the depth first search algorithm with logic and the code, right? So we are going to be exploring breadth first, right? So breadth first, not depth first. So what do I mean by breadth first? Well, I'll just explore the neighbors one by one, and then I'll be exploring their neighbors one by one. So let's see. So we are going to be maintaining few of the data structures in this case. So the data structures we are going to be maintaining are basically queue, right? So queue is a very basic data structure or a primary data structure which kind of supports operations like NQ and DQ. So in queue, you can kind of insert the element at the end of the queue, and the element can be then the element kind of comes out of the queue from the beginning, right? So you can kind of figure out that the element comes out from the front part, and the rear part is the part in the queue where you kind of insert the element, right? It's like a line, right? If you're in a shopping mall at the ATM section or in the ATM section, right? So you kind of come in a line and then you exit out of the front, right? So you kind of make sense here. So we are going to be maintaining a queue here. So I'm just kind of representing it in the form of an array as of now, right? That's not an issue. We are also going to be maintaining one thing called visited, but hey, that's just self-explanatory. I'll be explaining that in the code, but as of now, I'll just write it visited, right? Visited is nothing but a set as of now. So visited is going to be a set, right? So visited is my set, and let me just quickly erase this and represent it by curly braces because that's the representation of set, as we all know, right? So we are maintaining queue, visited, and then we can maintain one array called path. We can maintain one array called path just to store whatever the path traversal or the breadth first search path traversal is. Okay. Now that we know that these are the important data structures we are going to use, let's get started with the process. So in this case, in our case, we have an undirected graph, right? What does an undirected graph means? It means that I can go from node 1 to node 2 and node 2 to node 1. You kind of figure out, right? So it's vice versa. And in a directed graph, you can kind of go from node 1 to node 2, but not from node 2 to node 1, wherever the arrow mark or representation is, right? So we have a undirected graph here, right? Kind of looks like a tree, but we don't care, right? So we are going to be starting a BFS or breadth first search at the node 1. Okay, we are going to be doing a breadth first search at node 1. Again, there is no restriction. You can do a breadth first search at node 5 also, right? That's not an issue. But as of now, I'm starting a breadth first search at node 1. Okay, so I'm just going to write quickly BFS at 1. This is going to be my function, right? Or my iterative code. I'll be writing the iterative code. So basically, I'm doing a BFS at node 1. Okay, so I'll pick up the node 1 and put it into the queue. I'll pick up the node 1 and put it into the queue. As simple as that, right? No drama. What I'll be doing now is picking up the first element or the first node in the queue and exploring it, right? So what I'll do is just cross this. So I'll just cross 1 here and put it into the path, and I'll kind of explore 1. So I'm kind of exploring 1. What do I mean by explore? I'll be exploring its neighbors. So from 1, I'll check that, well, where I can go from 1. From 1, I can go to 2 and 3. So I'll just add 2 and 3 to my queue, not path. Okay, I'll be adding 2 and 3 to my queue. So I'll add here 2 and 3, right? As simple as that. Now, what I'll be doing is I'll check that, okay, I have got all the explored or the neighbors of 1 in my queue. Now I'm done. Also, I'll add 1 to my visited, right? Now I'll pick the next node, right? I'll just pick the first node in my queue. Now you will say that, well, my first node is 1, but I won't pick that because it's already visited. That's something you have to validate or check for, okay? And that's something which you cannot do in an interview. So 1 is already visited. So the first node in my queue is 2 and not 3, right? That kind of makes sense from the representation here. So it's 2 as of now, okay? So what I'll be doing is just cross mark 2, right? I'll put it into the path. Okay, I'll put it into the path and explore 2. So I'll also kind of put it into the visited and I'll explore 2. Once I cross it, I explore 2. So I can, from 2, I can go to 4 and 5. I can go to 4 and 5. So I'll just put in 4 and 5 into the queue. It's as simple as that, right? Now that we are done with this, I'm again going to be picking the firstmost node in the queue. So again, it's 3, right? So I'll crossing 3, I'll put it into the visited, I'll put it into the path, right? And then I'll be exploring 3. So I can see here, well, 3 is having no neighbor nodes. So should I put anything in the queue? No. So my queue is going to be unchanged as of now. And again, visited, we have the 3 in visited and then we have the 3 in path as well, right? And this is path, if you are still wondering with my bad handwriting. So this is the path. Now that we are done with this, again, we'll pick the next node. As of now, it's the first node in the queue, which is 4, right? So I'll put in 4 in the visited and I'll put 4 into the path. As simple as that. So once I've crossed 4, that's not the end point. I'll explore 4. So once I go to 4 node or the 4th node, I'll check that does 4 has any neighbors? You might say that, well, 4 has the neighbor 2, right? But that's not the case, right? And 2 is because visited, right? So I won't visit 2 again. So that's where the visited array or the visited set comes into play, comes into the picture. So from 4, I see there is this one neighbor 2, but it's visited, right? So I don't do anything, right? So 4 is having as of now no neighbors, right? So this is it. Again, I'll be picking the first node in the queue, which is unvisited as of now, which is 5, right? It is 5. So I'll put 5 into the visited. I'll put 5 into the path. That's it. I'll also explore 5 as of now because I cross mark it, right? So I'll explore 5. From 5, where can I go? I can go to 2. I can go to 8, 6 and 7. Well, should I really be going back to 2? No, because 2 is already in visited. Should I go to 8, 6 and 7? Yes, I can, because 8, 6 and 7, all of those three are not in visited, right? They are not in visited. So I can go there. So what I'll be doing is, I'll just kind of remove that mark. So I'll put 8, 6 and 7 into my queue as of now, right? As simple as that. Now, again, I'll be picking the first node in the queue, which is 8. I'll cross mark it. I'll put it into the visited and I'll add it to the path. I'll explore 8 because I cross marked it. From 8, where can I go? I can go to 5, right? From 8, I can only go to 5 and there are no other neighbor nodes. Well, can I really go to 5? No, 5 is already in the visited set. So I cannot go to 5. That's the catch here, and this is why we are maintaining a visited set here. Or you can, in your case, you can maintain an array, right? Or a memo or a dictionary, whatever you feel comfortable with. And again, I'll just explore 6 and I'll add 6 here and I'll add 6 to the path. And then I'll explore 7. I'll add 7 to the visited set and then I'll add 7 to the path. So my path, final path is going to look like 1, 2, 3, 4, 5, 8, 6 and 7. As simple as that. Okay. Yeah, we are done with the path representation here, right? So 1, 2, 3, 4, 5, 8, 6, 7, right? It's as simple as that. Now you might be saying that, okay, it's just the numbers, right? So 1, 2, 3, 4, 5, 6, 7, 8, kind of like that in that format. But that's not the case here. Notice one really cool pattern here. I'll just change the color. Notice that we are actually doing a level order traversal of the given graph, right? This is why I have represented this in the format of a tree. So we are kind of doing a level order traversal. Now check what I'm trying to say here. So just forget about the path as of now. Just forget about the path. So just imagine that, well, I don't have any path as of now. So how do I do a breadth first search starting at node 1, right? So BFS at 1. How do I do that? Well, the simplest approach is to do a breadth first search, a level order traversal of the entire graph. What do I mean by level order? So what do I mean by level order? That's the case here. You might be saying, what's level order? So I just got rid of that. So consider this is a building, right? Consider this is a building. So just consider that this is the first level. So what's the second level? It's this one, right? Third, and then so on till nth level, right? This is the nth level. So we are kind of doing a level order traversal in the graph representation. So let's see if my statement validates our output path. Okay, so I'll kind of go here and I'll kind of draw the graph again just for clarification. So 1, 2, and then we have 3 here, right? We have 4, 5, and then we have 8, 6, and 7, right? As simple as that. Now let's just draw some levels here. How do I do that? I'll just draw a level like this. So maybe I'll use a different color. So this is my first level, right? This is my first level. This is my second level. This is my third level. And this is my fourth level, or the last level, right? So fourth level. And all of these are levels, kind of like that. So what did I just said? I'll just do a level order traversal. I'll do a level order traversal. As simple as that. So let's just pick elements in order, level by level. Okay, in order, level by level. So what will my path look like? So my path is going to look like this. So these are the levels here. So imagine I have a path here, right? So my path is going to look like this. The first level, right? So I'll pick 1. The second level, I'll pick 2 and 3 in order, right? I'm not picking 3 and 2. That's not what I'm doing. I'm picking in order. So 2 and 3. So it's 2 and 3 here. We are picking 4 and 5 in order, right? So that's 4 and 5. And then we are picking 8, 6, and 7, which is the last level, fourth level. So in order, 8, 6, and 7. So I'll just write 8, 6, and 7, right? Now, just validate this path output we got from this path, right? Just validate this. So you can kind of figure out here that, hey, the path we are getting here, right? 1, 2, 3, 4, 5, 8, 6, 7 is actually the same as the path we were getting here, right? The one where we kind of did a, like the naive breadth first search algorithm thing, right? So 1, 2, 3, 4, 8, 6, 7. It's the same thing. So even if you forget in an interview that what was breadth first search, you can kind of draw a little diagram like a tree in a tree format, like I've done here, and then explain it to the interviewer that actually we are doing a level order traversal when we are doing a breadth first search, and that's also going to fetch you marks or fetch you points in that case, right? So I think that's enough for the explanation, and I think I should just start with the coding part, right? So also about the graph representation. So here I'm going to be representing the graph in the format of adjacency list. So adjacency list is one of those two ways by which you can represent graph. The other one is adjacency matrix, right? So a little terminologies here and there just to make you clear and revise you. So maybe I can just go to the Visual Studio Code here. I'm using Visual Studio Code and rewriting the code in Python. Okay. So bfs.py, I've named the file as bfs.py. I'll just create few things. Maybe I can just import something. So from collections, import default dict, right? And again, even without importing, I can do this. So what I can do here is without importing, right? So in an interview, definitely you won't be allowed to import. So what I can do is I'll just maybe like write some of the prerequisites here. So now that this has been done, I'll create my graph here. So my graph is going to be memo, right? So like kind of like that. So memo in Python is called a dictionary. I mean, dictionary in Python it's called a dictionary. I believe in JavaScript it's called a memo. In C++ it's called an unordered map. In Java it's called a hash map. Yeah, I might be wrong here and there, but that's it. So in Python it's called a dictionary. Alternative, you can use unordered map, hash map, or memo in whatever your case is, right? So I've created one thing called graph here, which is going to be containing the representation. What are the inputs here, right? What are the inputs here? So what I'll be doing is, maybe I can just check whatever the count of inputs I had here. So I had 1. So what will be my input here? I'll just kind of draw here. Perfect. So what are the inputs here? Valid inputs here. So my inputs are, so these are my inputs going to be. Inputs. I will have inputs in the form of nodes, right? So one node is going to the other node, kind of like that. So I'll have 1, 2 and 1, 3. So I'll have 1 to 2, 1 to 3, because that's where the edge is going. I will have 2 to 4 and 2 to 5. So I'll have 2 to 4 and 2 to 5. Then I'll have 5 to 8, 5 to 6, 5 to 7. So 5 to 8, 5 to 6, and then 5 to 7, right? These are all the valid inputs which I'm going to be inputting in my program to have this graph internally, right? Diagrammatically or visually, imaginary thing, right? So how many inputs are there? That's 1, 2, 3, 4, 5, 6, 7. So I'll be running a loop for 7 times, right? I'll be running a loop for 7 times as of now. So what I'll do, I'll just run a loop. So for I in range 7, because hey, that's how you run a loop in Python. Then I'll have a node 1 here and then node 2 input, and then I'll kind of map them, right? I'll just kind of map them to integer format. I'll just split them. Now I'll check that if node 1 is not in my graph, right? If node 1 is not in my graph, then I'll just create it, right? So graph of node 1 is going to contain a list, right? It's going to be a list, right? Because hey, that's what the adjacency list is, or the adjacency list representation is, node 2, right? Else what I'll do is that the node 1 is already there in my graph. I'll just append the node 2 value to the already existing list. That's it. No drama, right? And again, I'll just do the same for the node 2 here, right? So it's going to be the same for the node 2 here as well. So what I'll do, just copy paste it. So it's actually not working here. Maybe, okay, I'll just kind of do it here. So if node 2, right, not in my graph, right, then what I'll do is graph of node 2 is going to be basically the node 1 value, right? As simple as that. Else my node 2 is existing in the graph, and then I'll kind of append the node 1 value to the already existing list. It's as simple as that, right? And I'll kind of check in between if we are on the recording page. Yeah, we are good to go. Perfect. Now that I've done this, right, so our graph is ready. As of now, our graph is ready. So what are the few data structures which we are going to be using? We are going to be using a set in my case. So that's a set visited, right? I'll use a queue, right? I'll use a queue. It's an array as of now. And I'm considering my start node to be 1, right? My start node is 1. So I'll just write start node is 1, right? So in my queue, I'll add 1. As of now, in my queue, I'll add 1. And also in my visited set, I'll add 1, right? I'll add 1. So why did I not write add here? Well, in a list, which I treat a list as an array in Python, so we have to add with the operation append, kind of appends it to the end, right? It's self-explanatory, the term. And in a set, when we want to add anything, we use the add, right? So dot add, functionalities in Python. Now that we are done with this, I think we are left with the path array. So this is going to contain the path, right? What we are going to be doing is, maybe I can have 1 already in the path, or I'll have 1 in the iterative approach, right? That makes sense. So let's see what we can do here. So I'll do an iterative approach. One small task after the iterative approach, or understanding the iterative approach from your end, is going to be implementing the recursive approach, because that's going to be helping you to learn about recursion as well. Okay. So I'll check that while my queue exists, right? So while queue will do, or I can also do while len queue. So while len queue, right? Or I can also do while len queue is greater than 0, or I can also do while len queue is greater than equal to 1. You can get creative with that, right? So I'll just do the fair one. So while length of queue is greater than 0, then my current node is going to be the first node in the firstmost node in the queue, right? So the first value in the queue. So I'll just write q of 0 because hey, to access the firstmost element in an array, we use the indexing, right? So 0 is this 0 kind of is the starting index in the array, right? So q of 0. Now what we are going to do is basically pop off or get rid of the first node, right? So for example, you are in a ATM line, right? You are in an ATM line. Now it's your turn to get the card. I mean, get the cash, right? You kind of got the cash, so you won't be really there, right? You should move out of the queue. So where are you actually moving out of the queue for others to enter the ATM? You are actually moving out not from the end, right? You're moving out from the front. So that's why what I'll be doing is get rid of the first node value in the queue, right? It's as simple as that. So how do I do that? We are going to be implementing something called q.dequeue, right? Kind of gets rid of the element at whichever position you want it to be. So in my case, I'll just write q.pop, and in the pop parameter, I'll be having the index where I want it to be popped off. So 0. I want it to be popped off from 0. So this is equivalent to kind of like a dequeue operation, right? I hope that makes sense. Now that I have the current node, right? I have the current node as of now, right? I have the current node. I'll just highlight that. So what I can do here is one small trick, or not a trick, we have to do that. Explore current node. Explore current node. As simple as that. So what I'll do, I'll go like for neighbor node in graph representation of current node, right? So for neighbor node in graph representation of my current node, right? What I'll do, I'll check that if my neighbor node not in visited, what does this line do? So this line is checking that, okay, the node I'm exploring as of now, is it not in visited? Then I'll visit it. Else I won't visit it, right? It's as simple as that. So for example, this is the visited set. A node 5 is already there. So will I visit that again? No, right? So that's what this line is checking. If neighbor node not in visited, is 5 not in visited? So for example, 3 is not in visited. So I'm checking, is 3 not in visited? No, it's not in visited, right? So I'll explore it and then add it to visited. As simple as that. So what I'll do, my next step will be to visited dot add what, 3 or 5? No, the variable name, neighbor node, right? So it's going to be neighbor node. As simple as that. Next step, I'll be adding that thing. So q dot append neighbor node, right? Because hey, that's what we were doing. We are exploring the current node, and whatever the nodes were there, the neighbor nodes, we are adding it to the queue. And also we are kind of, in this case, adding it to the visited. So kind of makes sense here. Okay. Now what I'll be doing is, now that we are done with this, I'm left with the path operation. So when and where should I be appending nodes to the path, right? You can kind of pause the video as of now and think of it. And if you have already figured out, cool. If you haven't, it's okay. So let's see. We can kind of write, put the current node in the path up here as well, right? So I can kind of here write that put the current node in the path, right? So put the current node in the path, as simple as that. Okay. So what will be the operation? It will be simply path dot append current node, right? As simple as that. No drama, right? And I think we are done with this. I hope so. Let's see. If we are somewhere wrong somewhere, we'll figure it out. Okay. Now, kind of, I'll just write here that print the path, right? So that's going to be printing my path. So I'll just save it. Let's see if this is going to work, right? You can kind of pause the video and dry run with several codes. Let's kind of dry run together, right? So we had something like 1, 2, and 1, 3, right? So what will happen is, firstly, we have 1. It will take in 1 into the path, right? And then it will explore kind of, it will add 2 and 3 into the queue, right? Again, it will take 2 and add it to the path. Again, it will take 3, add it to the path. And well, it's okay, right? Let's see. I'll kind of drag this up a bit. And the file name is bfs.py, right? So I'll try to write here Python 3 dfs.py, right? And then maybe we'll see whatever the input was. So our input was, in our case, the input was 121324, right? So 121324. So I'll write 121324, right? Let's see the other inputs. So 121324, 2558. So we have 2558, right? And then we have kind of like 5657, right? So 56, and then we have 5 and 7, right? And this is the entire breadth first search traversal here. 1 2 3 4 5 8 6 7, right? As simple as that. That's what we even get. Let's validate it. 1 2 3 4 5 8 6 7. Let's see if it matches our prediction. So our prediction was this, right? Our prediction was this. So this was our level order traversal. 1 2 3 4 5 8 6 7. And you can kind of shuffle the inputs here and there, the node values, and figure out whether we are right or not. Okay, let's just do it in front here, right? So consider this input 1 10 9, maybe 5 11 12. Just a small graph here, right? Kind of like representing in the format of a tree, right? So what will be the input here? My input will be 1 to 10, then 1 to 9, right? Then we have 10 to 5, we have 10 to 11, then we have 9 to 12, right? So that's 9 to 12. I'll just kind of put some spaces here. Perfect. So this is all the input is. So 1 2 3 4 5, 5 number of inputs, right? 5 number of inputs. What I'll do is I'll kind of quickly go and modify this thing. So my loop is going to run for 5 times. Perfect. I'll just save this and I'll go back to there and check, well, what will be my predicted output. So again, just draw some levels here. Draw some levels. This is my level 1, level 2, level 3, level 1, level 2, level 3. What will be my traversal? Level order traversal. So I'll pick 1 here, right? So this is going to be my path, right? Or the traversal. So 1 will be there. In order, 10 and 9 will be there. So 10 and 9 is there. Then we will have 5, 11 and 12, right? So we will have 5, 11 and 12. As simple as that, right? So 1, 10, 9, 5, 11, 12. 1, 10, 9, 5, 11, 12. In level order, in order, right? So level order and in order. Let's see if our output matches this. So just remember this as of now in the back of your head. 1, 10, 9, 5, 11, 12. Perfect. I'll kind of go here and then try to get the inputs here. So what was our input? 1, 10, 1, 9, 10, 5, right? So 1, 10. Oh, my bad. So I'll just kind of do it again. So 1, 10, 1, 9. So that's 1, 9. I'm pretty bad at taking inputs, I guess. 10, 5, 10, 11. So that's 10, 5, 10, 11, right? And then we have kind of 9 and 12. We have 9 and 12. Let's see. So we have 110. As you can see here, we have 110, right? I'll just kind of get this up here. We have 110, 9, 5, 11, 12. 110, 9, 5, 11, 12, right? So up here as well, we had 110, 9, 5, 11, 12. It's as easy as that, right? It might take you some time to grasp the concept, even for both breadth first search and depth first search, but it's worth it. Because why I'm saying it's worth it? Because several algorithms or several interview questions, which I'm going to be covering in future, kind of has a base of DFS and BFS, because we are using the concept of BFS or DFS, whatever it is, in those questions, right? So you have to be clear of that. So for example, if I say you today that, hey, write your name. So I am writing my name here, it's Vaibhav, right? But will I be able to write my name if I don't know the letters of the alphabets? So if I don't know V, if I don't know A, if I don't know Z, then will I be able to write this? No, right? So these are kind of the basic building blocks. In this case, our building blocks is DFS and then BFS, right? So that's something which you have to understand, right? And I hope the video was helpful for you. And if you find the video helpful, make sure to subscribe, comment if you want to, and we will maybe meet in the next video with another interview question. So thank you.